This is Mrs. O'Neill for Chapter 12, Section 3, Part 2, Limiting Reagent Example Problems. So again, pause the video, fill in those blanks, read as you write, and then play to hear my words. So guys, we are going to use stoichiometry to figure out these limiting reactant problems. And in essence, you're doing two stoichiometry dimensional analysis problems, just like he did in the video, Mr. Anderson, that Bozeman science video. So these are the steps, ladies and gentlemen, to using stoichiometry. It should look really, really familiar. Most of these blanks you filled in before. So number one, yeah, you're going to convert the starting quantity of your substance you have to moles. Mole island. Step two, very similar. You're going to use that mole ratio from the balanced equation to go from the substance you have to the substance you want. Step three is where it's a little different. This is where you're going to stop, and you're going to have to compare those moles amounts. Remember, you're doing 1 and 2 twice for two different reactants. So number three, you're going to stop and you're going to choose the less moles. You're going to continue the problem with this substance that gave you the less moles of the product that you want. And number four, then you can finish and you can take your substance that you want from the moles, that again, the less moles, to the quantity that's being desired. Again, I'm going to show you some examples to help you through this. It's a lot easier that way. So again, here's our setup. Looks familiar, right? I will tell you that Mr. Anderson on the Bozeman Science, he basically did two stoichiometry problems. He went all the way through. He went from your quantity to moles, used that mole ratio, and then went to the quantity. I'm going to change this just slightly and say stop here. We're going to stop at the moles because the smallest number of moles is really what's going to be important. If for chemists, remember chemists, the mole is the most important unit. And that's why we're going to stop here, and then we're going to convert to any quantity at the end. This way, again, guys, we're not doing extra work. We're not doing work that we don't need to do. So we're basically doing the stoichiometry problem 2 times, but we're stopping at the moles of what we want. We're going to equal it there and then finish the problem. So again, very similar to what you've seen before. You're going to do the stoichiometry problem twice. So this beginning part, you're going to do 2 times, 2 different reactants. Then we're going to stop here and we're going to say, okay, which of those problems gave us the least amount of moles? Which reactant is going to give us the least amount of moles of the product that we desire? And again, moles doesn't usually help chemists as far as measuring, right? So that's when we do that extra step and go to one of these quantities that we can actually use. All right, guys, some reminders as always, because we're dealing with stoichiometry, we want to include a number, a unit, and a substance for all of those parts in our dimensional analysis setup. And that mole ratio is the only time we're using those coefficients. We're not using those coefficients any other time except for that mole ratio. So if you don't have this out already, you need a real periodic table, an ion chart periodic table, and your calculator. So moving on to example 1, sometimes this is the first or the easiest way, I should say, to get you to understand how to do these problems. So read that first sentence and then come up with a balanced reaction. So pause and see if you can come up with a balanced reactions of this information. So hopefully, guys, you paused and you came up with this balanced equation. So from the balanced equation, now we can continue. Calculate the number of liters of hydrogen. Just like we did in stoichiometry, I'm going to put the question mark in liters over hydrogen. So again, above or below. I actually have them above now just because I need more space here to show you the work. And again, you might want to listen to everything, and then I'm going to tell you when to pause to actually write everything into your notes. All right, so it says how much can be produced when 5 grams of aluminum, so I'm going to put the 5 G's above aluminum, and 7 grams of hydrochloric acid react with each other. So I'm going to put that above. So again, what did we say? Now that I have 2 amounts for 2 different reactants, but this is the substance I want, I'm going to do 2 stoichiometry problems until I get to the moles of hydrogen. So we're going to start with 5 grams of aluminum, grams to moles. Pause the video, see if you can find aluminum on your periodic table to get its mass. All right, so the formula mass is 26.98, again, to try to keep us all on the same page, round to 2 decimal places. All right, so that's grams to moles of aluminum. So we're going to go from aluminum to hydrogen using our mole ratio, right? In this case, it's a 3:2 ratio. Pause the video, do the mathematics. All right, guys, so when you do our 5 divided by 1 times 1 divided by 26.98 times 3 divided by 2 should give you an answer of 0.278 moles of hydrogen. All right, so that's how much moles of hydrogen can be made from that amount of aluminum. Let's see how many moles of hydrogen can be made from 7 grams of HCl. So again, pause the video and come up with the formula mass of HCl, 1H plus 1Cl. Hopefully you came up with 36.45 grams of HCl. And now again, a mole ratio. The mole ratio now is between hydrogen and hydrochloric acid. So it's a 3:6 ratio. Again, pause the video and do the math. 7 divided by 1 times 1 divided by 36.45 times 3 divided by 6 gives you an answer of hopefully 0.096 moles. Now let's compare. Which of these moles is in the lesser amount? Well, this guy is, which means HCl is our limiting reactant. Because that's our limiting reactant, now we can finish the problem. Now we're going to start at moles. This really looks like mole island problem now. We're going to go from moles to liters. When we're going to liters, guys, what number should come to mind? Hopefully you came up with 22.4. So now we have our moles times our 22.4 to get our liters of hydrogen. So now guys, pause the video, make sure you have a balanced equation, make sure you have your question mark and your amounts of reactants, and make sure to put in all of these steps for a limiting reactant problem. All right, guys, let's go on to number 2. Again, first you need that balanced reaction. Sometimes this is the toughest part, but make sure you have your ion chart and you should be able to read all of the information in order to come up with a balanced reaction. All right, guys, hopefully you came up with this as your balanced reaction. Now, again, think about where the question mark is going to go and where our numbers are going to go with what unit. So it says how many grams of sodium nitrate. So there's going to be my question mark with grams. I have 25 grams of lead nitrate and 15 grams of sodium iodide. Okay, so again, we have to do the stoichiometry problem twice, come up with the moles of sodium nitrate and do a comparison, and then we can finish the problem. Now I abbreviated here, so this is for lead nitrate. Again, we're starting with 25 grams. This is going to be our mole island. We're going to go from grams of lead nitrate to moles of lead to nitrate. So again, pause the video and see if you can come up with its formula mass. This is a good time again as practice. All right, so there's 1 lead, there's 2 nitrogens, and there are 6 oxygens. Using your periodic table and those masses, you should have came up with 331.22 grams of that lead to nitrate. Now we're going to multiply it by our mole ratio because we're going to go from moles of our lead to nitrate to our moles of our sodium nitrate, and we get a 2:1 ratio. Again, pause, make sure you can do the mathematics here. I get that as an answer. All right, but we have another reactant. We don't know which one's limiting yet, so we're going to have our another reactant of sodium iodide. Again, I just abbreviated SI for sodium iodide. We're starting with 15 grams. Pause the video and come up with that molar mass of 1 sodium and 1 iodine. And you should have came up with that. And then again, we're going to go from our sodium iodide to sodium and nitrate. So again, it's going to be, in this case, a 2:2 ratio. All right, pause the video and can you come up with the amount of moles? Hopefully you came up with that. All right, now we're going to do our comparison, 0.15 versus 0.10. Well, 0.10 is less, so our sodium iodide is our limiting reactant, and now we can finish the problem. So instead of moles, what do we want? We want grams. Back to the periodic table. Find the formula mass of sodium nitrate. Again, 1 sodium, 1 nitrogen, and 3 oxygens all together. And I got 85. I think it's 85.00, but for space. So again, pause, multiply that out, and what do you get as a final answer? 8.50 grams of sodium nitrate. So again, hopefully this is making sense. Our limiting reactant is limiting how many grams, in this case, of sodium nitrate we can make with the amount of reactants we have. And so if you notice, guys, I stop at moles and compare there. Why would I do this twice? Okay, I mean, if you did want to, you can, but ultimately, you only have to do this part once, not like Mr. Anderson, he did the total problem twice. You can stop at moles and continue that way. So again, pause the video and make sure to get all of this information into your notes packet. And the last one, what do you think? Can you do this? First, pause the video, see if you can come up with that balanced reaction, then try to pull out that question mark in the unit and your starting points. See if you can get all of that done before we continue the problem. All right, guys, so hopefully you came up with a balanced chemical equation. Hopefully you came up with the question mark of grams with the lithium sulfate, and of course our starting points of 115 grams of the iron 3 sulfate and the 145 grams of the lithium nitrate. All right, guys, why don't you give it a try? Can you set up the problem and find, let's start with the moles, find the number of moles of lithium sulfate that would be needed, and that's going to be our stopping point for our comparison. All right, guys, that probably took you some time, especially because you had to come up with the formula masses of our reactants. But here's the setup again. So here's your lithium nitrate. Oh boy, I forgot to change that. And I'm not going to change my video here. So this is your iron sulfate. Your iron sulfate goes to moles of sulfate, iron sulfate, and then to a lithium sulfate. And I got that for my moles of lithium sulfate. And then again, I apologize, I didn't redo my abbreviations there, but this is for lithium nitrate. So lithium nitrate, using its molar mass, I'm going to moles of lithium nitrate, and then again moles of lithium nitrate to moles of lithium sulfate, and I get that as an answer. All right, now, so I'm going to ask you again, why don't you pause, right? Now that you see the 2 moles, can you pause and can you come up with the end result, right? Which one are you going to use? In this case, guys, you're going to use the 0.86 moles of the lithium sulfate because the iron 3 sulfate is our limiting reactant, and now we can finish the problem. So using the molar mass of lithium sulfate, you can finish the problem. So hopefully mathematically, guys, you got 94.56 grams of lithium sulfate. So ladies and gentlemen, notice I'm always including number, unit, and substance for every single part and for the answer. So if you haven't done so already, pause the video and make sure to get all that information, and hopefully it's making sense to what's going on here as far as these limiting reactant problems. All right, guys, hope to see you in class.